I want to kick things off with a number that, frankly, when I first saw it in our show notes, I just assumed it had to be a typo. 1 million.
It's a staggering number.
Right. I mean, a filing with the FCC from late last year for up to 1 million satellites. And this isn't just more internet for your phone.
No, not at all. These are what they're calling compute nodes.
It's pure science fiction. You know, you imagine this swarm of machines in the sky, but this is the business reality of early 2026. The whole pitch is to take the data center,
That big concrete box in Iowa?
that box, and just blast it into orbit. We're talking about orbital silicon, moving the actual brains of the internet off the planet.
It is the single biggest infrastructure shift since we went from mainframes to the cloud. And it's not happening just because it's a cool idea. It's a necessity. We're hitting a wall.
So that's the why now question, isn't it? Because we've been hearing about the AI boom for a few years, but I don't think people really get the physical toll it's taking on, the grid.
They don't. It's what people are calling the perfect storm. You've got the AI sector, which is projected to pull about 1,000 terawatt hours annually by the end of this year.
Which is what in real terms?
It's roughly the entire electricity consumption of Japan.
Wow. Okay.
And you can't just build more power plants overnight. You need transformers, substations, all this hardware, and the supply chain for that is backed up for years.
The grid is full. I keep seeing that headline. But the piece of the research that really surprised me was the water. I think of computers as dry,
Incredibly thirsty. And that's the silent killer of the old data center model. To cool these server farms, you're using evaporative cooling, sweating the heat away.
And that takes how much water?
The whole industry. About 1.7 billion gallons daily.
From 1.7 billion. That's a number that's hard to even get your head around.
It is. And we saw real consequences last summer with those water wars, right?
Yeah.
Hyperscalers like Microsoft had their water curtailed. I think it was 500 million gallons in the Midwest because aquifers were dropping.
It's the ultimate NMBY problem, not in my backyard. Everyone loves what AI can do, but nobody wants that power-sucking, water-guzzling fortress built next door.
And that's before you even get to things like the EU's new carbon taxes.
Yeah.
So the industry is looking at the chessboard and realizing, Earth is resource constrained.
Whereas space is empty. Or as the pitch decks say, it has infinite land and endless solar.
It has two critical things Earth doesn't. Unfiltered, constant energy in a vacuum.
But gravity has always been the argument against this, right? Gravity is expensive. In the shuttle era, it cost, $50,000 to put 1 kilogram in orbit? You can't build a business on that.
Absolutely not. At 50,000 a kilo, you're losing money just launching a single hard drive. But that's why we're having this deep dive in 2026 and not 2016. The game changer is Starship.
The fully reusable rocket.
Exactly. With the launch cadence we're seeing now, the costs have just cratered. We're looking at numbers that are getting close to $10 per kilogram.
Wait, hang on. From $50,000 down to 10?
Yeah.
That's not an improvement. That's a completely different reality. That's cheaper than FedExing a heavy package across the country.
That is the single data point that flips the switch. At $10 a kilo, the Orbital DC, the Orbital data center, suddenly makes perfect financial sense.
So let's talk about what's actually going up there. The filings say they're based on the Starlink V3 platform, but they're not just reflectors.
No, they're flying server racks, literally. Custom boards packed with, NVIDIA, AMD GPUs, all stripped down for space. No fans, no bulky plastic casing, just silicon.
And powered by the sun. But this isn't like the solar panels on my roof.
Oh, it's vastly better.
Yeah.
On Earth, you've got the atmosphere, clouds, night, all cutting your efficiency. In low Earth orbit, you get almost constant unfiltered sunlight. We're talking 99% uptime.
So you basically have a free nuclear reactor in the sky powering your chip. No grid, no transmission loss.
And no utility bill.
Okay, my physics brain is tingling now. These things are moving at 17,000 miles per hour. A server in Iowa just sits there. How do you wire these things together when they're screaming across the sky?
That was a big hurdle. You can't use copper wires, obviously. So they use light, lasers, optical interlinks connecting each satellite to its neighbors.
Like a mesh network in the sky.
A true mesh, yeah. Pushing 200 gigabits per second between the nodes. But here's the really wild part. Light is actually faster in space than it is in a fiber optic cable.
Because of the glass, right. The refractive index slows it down.
You nailed it. In a vacuum, light moves at its true top speed. In glass fiber, it's about 30% slower. So for certain routes, say London to New York, going up to space and back down, is physically faster than using the undersea cable.
Which is everything to a high-frequency trader. I mean, those firms spend millions to shave off a few milliseconds.
Exactly, and they're effectively funding the build-out of this early infrastructure.
Right.
But for AI, it enables this concept the architects are calling a cosmic cloud.
I saw that phrase, yeah. And nomadic neurons.
It's a great metaphor, because the satellites can self-organize. If a pharma company needs a supercomputer for a protein folding simulation, the constellation can group, say, 5,000 satellites to work on that one task for an hour.
And then they just disperse for the next job.
Right. It's a brain that reconfigures itself on the fly.
It's incredibly cool. But, and there's always a, but let's go back to cooling. Space is cold, sure, but it's a vacuum. It's a thermos. Heat has nowhere to go.
You've hit on the single hardest physics problem they had to solve. On Earth, you just blow air or pump water. In a vacuum, you only have one option. Radiation.
So you just, what, beam the heat away?
Pretty much. They have these huge radiative cooling panels. Think of them as the opposite of solar panels. They're coated in a special material that's incredibly efficient at emitting infrared radiation.
So they point them away from the sun and Earth at deep space.
And the heat literally radiates out into the void as light. We're solving our water crisis by dumping our waste heat into the universe.
Which, I guess, can take it. Okay, so free power, waterless cooling, faster data. It sounds too perfect. I'm a cynic. What breaks? What's the nightmare scenario?
The nightmare is radiation. Cosmic rays.
Right. Our atmosphere protects everything down here.
Exactly. In orbit, you're getting bombarded by high-energy particles, and they can cause bit flips. A particle literally hits a transistor and flips a 0 to a 1.
Which is a disaster if you're running a bank or flying a plane.
Error rates can be 1,000 times higher in space.
1,000. So how do you solve that? You can't just wrap them in lead. It's too heavy to launch.
You use redundancy. The voting logic. Instead of one processor doing a calculation, you have 3 do it at the same time. If 2 say the answer is 4 and 1 says it's 5, the system just ignores the odd one out.
Democracy for silicon.
In a way, yeah. Plus you have new radiation-hardened chips coming out. But still, things will fail. And when they do, you can't set a technician up in a van to swap out a bad server.
Which brings up the junk problem, Kessler syndrome. If you launch 1 million of these things, and even a tiny fraction fail and collide...
It's a cascading failure. Collision creates a debris cloud, which causes more collisions. It could turn low Earth orbit into a shrapnel field that basically traps us on Earth for decades.
That feels like a pretty high price for faster AI.
It is, which is why the regulations are getting so tight. The whole system has to be actively managed by robots, little shepherd satellites that grab dead servers and drag them down into the atmosphere to burn up.
A Viking funeral for a data center.
It has to be a managed ecosystem from day one.
Okay, let's talk user experience, because there's a nuance here. If I'm a gamer, am I going to be using an orbital data center for my next session of Call of Duty?
Probably not. And that's where the speed of light thing gets tricky. Yes, light is fast between the satellites, but the signal still has to go all the way up to space and then all the way back down. That round trip adds latency.
The downlink is the choke point.
Exactly. So space is perfect for what you'd call compute-heavy data-like tasks.
So, like training an AI. I send up a small request, learn all of organic chemistry, and the system thinks for a week and sends back a tiny file with the answer.
Precisely. Or climate modeling, drug discovery, heavy thinking, light talking. For something like gaming where you need that instant twitch response, you'll stay on the ground.
So Earth is for reflexes, space is for deep thoughts?
That's a great way to put it. That's the division of labor that's emerging.
Now, we've been saying SpaceX a lot, but this isn't just their game, right? This feels like a new gold rush.
Oh, everyone is in this fight. China is a massive player. They have a company, ADA Space, with a very aggressive plan.
And I'm guessing their goals are slightly different.
It's about sovereign clouds. China doesn't want its national AI development to depend on American infrastructure. They're building a parallel system.
So if a U.S. satellite is processing data while flying over France and then China, whose laws even apply?
That is the billion-dollar legal question right now. Data sovereignty used to mean the server was on your soil. These servers are on everyone's soil every 90 minutes. It's a jurisdictional nightmare.
So what about the other big tech players? Is Google just sitting this out?
Not at all. They have Project Suncatcher, but they're playing it differently. Instead of focusing on launching hardware, they're focused on the software layer. How do you write code that can run efficiently on these unreliable, high-radiation systems?
Of course. Let someone else build the hardware, they'll build the android for orbit.
It's a classic smart play.
Let's talk money before we wrap. How does this change the business model for, say, Amazon or Microsoft?
It completely inverts their capital expenditure. Right now, you spend, say, $10 billion and wait 4 years to build a new data center campus. It's a huge upfront risk.
And the tech might be obsolete by the time you open the doors.
Correct. Space lets you do what's called space arbitrage. You can launch capacity in smaller chunks, or, and this is the killer app, you can just lease it. A startup can rent a supercomputer for an hour on a Tuesday.
So it turns computing into a pure utility, like electricity.
Exactly. And because the operating costs are so low free solar power, no ransom analysts think this could cut the cost of AI training by 50%.
That is a massive disruption. If your business is owning those concrete buildings on Earth, you have to be sweating right now.
You should be. The forecast is for 20 to 30% of the world's AI workload to move to orbit by 2030. That is a huge slice of revenue leaving the planet.
But the ground stations, they stay. The Earth becomes the dock.
The future is hybrid, yeah. We upload the questions, download the answers. All the heavy lifting happens up there, in the vacuum.
The cosmic compute epoch. That phrase from the research really stuck with me. We're shifting from seeing space as a frontier to seeing it as a factory floor.
And honestly, it's the only sustainable way forward. We can't keep boiling our rivers and maxing out our grids to fuel this growth. We have to go where the energy is abundant.
I want to leave our listeners with one final idea from their research, something that felt almost poetic, the concept of photosynthetic brains.
Yes, that's the speculative far-out edge of this.
The idea that these systems might stop being just dumb boxes we control. They're using sunlight to power their silicon synapses. They're using AI to optimize their own orbits to find more energy or avoid debris.
They start to become semi-autonomous organisms. They eat light and they produce intelligence.
And if they can move and think and power themselves, at what point do they stop needing us down here?
That is the question, isn't it? If the cloud can literally float away, maybe one day it just does.
Becoming a new silicon-based layer of life above our biological one?
It's a humbling thought. We're building the infrastructure for a mind that might eventually outgrow its parents.
Definitely something to think about the next time you see a satellite flare in the night sky. It might not just be reflecting light, it might be thinking.
A factory floor among the stars.
Thanks for this deep dive on orbital silicon. It really is a brave new world up there.
Indeed it is. Thanks for having me.
Keep looking up, everyone. We'll catch you on the next deep dive.